All right, we're going to do stretches and shrinking. So we're going to start with the vertical stretching and shrinking. So in this case, fx is still going to be function. C is going to be positive real number. So if C is greater than 1, what's going to happen here is that the graph of y equals C of fx is going to be the graph of y equals fx, except vertically stretched by multiplying each of the y coordinates by C. That means if I had a point at xy, this here, the C is directly on the outside, so it's on that fx. So think C of fx is just doing C of y. This would be the same set of points, except x values stay the same and the y values are all multiplied by C. But in that case, you should be stretching vertically. So it means my graph should like stretch, getting taller. If, however, your C is between 0 and 1, well, this is going to seem pretty much the same. Y equals C of fx is going to be the graph of y equals fx, but it's going to be vertically shrunk. So everything's going to squish down by multiplying each coordinate once again by C. So we had a point x, y here. We'd still be looking at a point, those points to be x, y here. So it's just that vertical part, those y's, they're getting multiplied by that C. So it's going to cause those y values to stretch or to shrink. We're going to use fx is equal to the square root of x. And we have a point here at 1, 1 again, because the square root of 1 is going to be 1. There we go. I'm just trying to make this open. So here, if I just on the outside multiply everything by 2, what we see is this graph has gotten taller. This is a vertical stretch. And this is the same as saying this is just 2 times the square root of x. So we see that what happened here, we said y components get multiplied by the number out front, that C. 1 is stretched, and now it's going to be at 1, 2. We have fx again, but let's say we're going to multiply by 1/2. So 1/2 is going to be between 0 and 1. And what we see happens here is that when we multiply by 1/2, everything squishes down. So now we have a point 1 and 1/2, because that y component gets multiplied by that 1/2. So everything gets compressed, or we say it shrinks. So this is just 1/2 of square root of x. So this is your vertical stretch and compression. Or sorry, vertical stretch and shrinking. Your book uses shrinking, doesn't use compression. Once again, anything horizontal is going to do the opposite what happens when you do it vertically. So if once again C is less than 1, then the graph of y equals f of cx, so C is directly on the x now, is the graph of fx shrunk horizontally by dividing each of its x coordinates by C. So we would have an xy here, but those points are going to change to a x divided by C y. And once again, we're dividing by that C to cancel out the fact that we're multiplying inside the function. So it's once again to make sure we keep those same y values. So remember, we're dividing this time. So however, if we're between 0 and 1, then this is the graph of y equals f of cx is going to be the graph of y equals fx. Everything is going to be horizontally stretched this time. So like I said, the opposite of what happens when you're on doing a vertical stretch, and then we're still dividing all your x coordinates by C. So I have x, y here, and then we would have x divided by c, and y would be those same components. So this is a thought here. What's going on is that let's say we're going to have f of x is going to have the points, let's say 1 and 2. And then we're going to have 4x over here. Well, that means what's going to happen is that we're going to take that 1 and we're going to divide it by 4. That point is going to turn to 1/4, 2. Down here, if fx is the same point of 1, 2, this is how we're seeing that shrinking there because my x's are getting smaller. Over here, I do a similar thing. So this time I'm going to do f of 1/4 of x. Put that in the wrong place. Then what happens is we take that 1, but we're dividing by 1/4 and 2. So we are taking it and dividing by a fraction, so that's going to flip. And we end up with 4, 2. That's how we get that stretch. So when we're dividing by something that's between 0 and 1, we're getting fractions, and those fractions are going to turn into reciprocals that are multiplied onto our x values. All right, so we're going to use the absolute value of x. So this is this function right here. It's my fx. And now I'm going to go directly on the x, and we're going to multiply by, let's say, 3. So we will pick, that's a good point. Let me expand this just a little bit so we can see this a little easier. So this point here is at 1, 1. And what we see is it's moved into here. So it's moved to a point that it should be. Sorry, we're dividing by that 3, so it's going to turn it into a point, make this a little bigger. 1 divided by 3, so 1/3. But y is still 1, so it's moved in by a third. You can see that, right? We split that up, it's about 1/3. So let's say instead, we're going to go directly on the x, but we're going to multiply by 1/3. There we go. Now what we see happen is that this point here has now, I gotta move something. There we go. Has now moved out this way and is now here. What this is 1 divided by 1/3 and 1, because y is still 1. Or, as we see, it's going to do that reciprocal effect. So 1 divided by 1/3 is 1 times 3/1. So this is just 3 and 1. So it is moved out and it is stretched out. This is what we're talking about. So this way, it's getting closer to the x-axis, those points, that's shrinking. Or sorry, the y-axis, getting closer to the y-axis, so that's shrinking. When it moves further from the y-axis, that is the stretching. So sometimes some people have a hard time seeing that part. If I rewrite these, this is just a 3x, and this is just 1/3, absolute value of 1/3 x. Value 3x, absolute value of 1/3 x. We are going to take this function here of fx. And what we want to do is we want to graph what 2 of fx would look like. So this 2 out here means that all my y components are going to be multiplied by 2. So this point here is at 1, 2, 3. So this is at 3, 0. So if you multiply that y component by 3, well, then you're just going to have 3 times 2 times 0 So that one's just going to stay at 3, 0. So just want to point out what happens with zeros again. We have a point here. That's approximately 1, 2. We're going to lie. It's not exactly at 2, but we're going to say it's at 2, -4. So what happens, I multiply by that 2, as that is 2 times the -4. So we're only multiplying the y component, so this turns into 2, -8. 1, 2. So make a new color here. This point is going to stay, and this point is going to turn into 6, 7, 8. There we go. That point right there. We get a stretch. We have a point here at 0, 0. So same thing. If I take 0 and multiply it by 2, it stays 0. Point isn't moving. That one's staying. Same thing here with this point, because this is also going to have a y component of 0, because this is 2, -2, 0. It's going to stay there as well. So if the y component is 0, it's going to stay. The only point we really have to think about here to kind of get this idea what's going on is this one. So this one's at roughly -1, 2. So -1, and then we're going to double that y component because of that 2 here. So that's -1, 4. So that moves up here. Let me change that color because our original line is red. So let me put blue on here and get rid of all these extra points. Okay, so we are going to, some places are going to look kind of the same, but we're definitely seeing at those minimums and maximums, we can really see that stretch going on. Do this part first. It's actually because it's getting skinnier. It's vertically stretching out. It's going to do this. Here we still have the same effect, but now we have a 2x. This means all my points are going to be x divided by 2 because we're directly on the x. So we start dividing, so multiplying y. Pick a couple points here. Once again, we have 3, 0. We have this point here that is roughly at, we see that was 2, -4. Point here at 0, 0. We have a point here, or roughly right here at about 1, 2. And then we have a point here. Some of them are kind of guessing where they're at. This one's -1, 2 at -2, 0. So what we're going to see here, we'll start out with this point and go across. The -2, 0, what's going to happen is that y component is going to get divided by 2. So that's now going to become -1, 0. So it moves in here. That point we have at -1, 2. The x component gets divided by 2. So that's just going to be -1/2 and 2. So it moves in here. This point at 0, 0. Well, we take 0 and we divide it by 2. And we're going to get 0, 0 back. So that point stays where it is. So if your x component is 0, that point's not going to change. If we take this point at 2 - 4, we divide the x component by 2. That's going to give me 1, -4. So I move into here. And then the last one, we have a 3, 0. So the 3, the x component gets divided by 2. I don't think I have to rewrite that one, but that's 1.5 and 0. So this moves into here. All right, I might not draw the line all the way down. points. So we can see that everything has squished in or compressed or shrunk by a factor of 2. And it is shrunk horizontally. All right, so try worksheet number 4 and worksheet number 5. So here we have our f of x divided by 4. And then here we have 1/4 fx. Let's graph these as best you can. Okay, so hope you had a moment. So once again, we're directly on the x. You can think about this as f of 1/4 of, and this is my fx over here. So we'll pick a couple points here. So we have a point here at 0, 0. We have a point here at 1, 1. And we have a point here at -1, -1. So what we see here is that we should be multiplying all our points by 1/4, or dividing them all by 1/4, I'm sorry, which is going to turn into basically multiplying them all by 4. So what we're going to have here is that this point is not going to be 1, 1 anymore. It's going to turn into 4, 1. My point at 0, 0, when I multiply my x by 0, becomes 0, 0. My point at -1, -1, when I multiply my x by 4, is going to be -4, 1, or -4, negative, sorry, it's good, -4, -1. Okay, so we are out here now at 4, 1. This stretch us out here to -4, 1. So we're getting a horizontal stretch, and 0, 0 stays where it is. So we have something that's going to kind of like this. As my new function. The 1/4 is on the outside. So what we're doing is we're getting points. We're getting points that x is going to be the same. So let's remember this is directly on your y. So all your y's are multiplied by 1/4. Once again, same point. We have -1, 1, -1, -1. The y is going to turn into -1, -1/4. We have a point at 0, 0. When I multiply my y by 1/4, it's going to stay 0, 0. Then my point at 1, 1. When I multiply the y component by 1/4, we're going to get 1 and 1/4. So you're going to see everything's going to shrink by a 1/4 vertically. So this point stays the same, but this is over here. This has gone down here. Okay, so if you have to do multiple transformations, it's always best to do everything that's in the parentheses first. So your horizontal shift, and then deal with any kind of multiplication there. So your stretches or compressions. Then you want to look at reflections. And then lastly, you want to look at your vertical shift. So like I said, this is sort of a step-by-step guide to kind of help you get through this. So it's kind of like you're following order of operations. Do parentheses first, do multiplications next, then you want to do your addition. So we have the graph of x squared, and we want to find our new graph obtained by doing these transformations. So we're going to get 2 times x minus 1 squared plus 3. So if we do parentheses first, just in here. All right, sorry, I had a little glitch there. If we do parentheses first, so we're going to do this part first. That is telling me that I'm going to shift horizontally. And because I'm subtracting, I'm going to shift in the positive direction. So shift right by 1. So if I do that, this shifts over here. We'll just shift 2 points. This shifts over here. That shifts over here. So we shift here. So I'm going to put these big red ones here. These are the points I'm going to shift initially. We'll figure out the rest of this as we go on. Then we want to deal with multiplication. So my second part is I'm going to deal with this here. So this is directly outside of the parentheses, so it's outside of your fx. Because if you want to, we can rewrite this. Oh, we should call this g of x. What we're saying here is that g of x is really just going to be x is the square, right? So we take the square, we subtract the 1, then we multiply by 2, then we add the 3. So we're looking at these transformations. This 2 is directly outside the parentheses, outside that x. So that is going to be a vertical shift or vertical stretch. So what we're going to see here is that my y components are all going to stretch by 2. So this here, this is going to be y is 1. So now y is going to move up to 2. Here y is 0, so it stays here. Here y is 1 again, so it's going to stretch up to that curve too much. So we got a vertical stretch going on. And then lastly, I'm going to erase some of these steps as I go along. We have this last part here. So like I said, do what's in the parentheses, then do the multiplications on the south side of the parentheses. Then you're going to do this addition. So this is on the outside of my parentheses of my x. So it's directly on that y part. This is a vertical shift. So we're going to shift up by 3. This point here is now going to move up 1, 2, 3. This point here moves up 1, 2, 3. And this point here moves up 1, 2, 3. So we could have just put in some XY pairs, and got an idea of the graph is, but this helps us very quickly see, oh, this is where this should be sitting. It should be moved over to the right by 1, shifted up by 3, and everything should have been stretched out by a factor of 2 vertically. So on your worksheet, you should have 6 and 7. So here we're going to do negative x over 4 squared plus 2. And then here we're going to take our x squared, but we want to shift it. So we have 1/2 of 2x squared minus 1. All right, so to go backwards, x squared is my fx. So here I took fx, but I divided by 4 directly on the x. Then I multiplied the x squared by a negative. Then I added a 5. So if I go in order, I have to deal with this first. So directly on the x. So this is going to be a horizontal shift, or not horizontal shift, I'm sorry, a horizontal stretch. And what we're going to see here is that we're going to have x and divide it by 1/4, which is just going to turn into 4x y. So all my x components, so this is 0, 0, x is 0, and change. This point right here, this is 1, 1. So x is at 1. It's multiplied by 4, so it stretches out to here. Here is at -1. It stretches out to 4, so it stretches out here. This point right here, x is at 2. So if we stretch that out, we're going to stretch out to 8. Here, x is at -2, so this will stretch out to -8. So we're going to see that horizontal stretch. So we did parentheses. Now we do multiplication outside the parentheses. So once we're outside, we got this negative, right? So the negative is outside of the function. So that means that this point here would reflect over here because the y component is going to be the part that, sorry, this point here is going to reflect down here because the y component is. So this is reflection over x-axis. So this point here moves down here because it's just the y that's turning from positive to negative. This one's at 1, 1, or 0, 0, I'm sorry, 0, 0. It's going to stay here. This point here, y is at 1, so now y is going to be at -1. Here, y was at 4, so now y will be at -4. Here, y is at +4, and y is going to shift down to -4. And then lastly, we're going to do our addition. So we are going to shift up 5 because that's outside of the fx. So this moves up to 5. This moves up 1, 2, 3, 4, 5. This point moves up 1, 2, 3, 4, 5. This point moves up 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. So that is my transformed function. All right. Once again, go inside the parentheses first. So we have 2x. That means, once again, because we're multiplying, this is a horizontal. Because we're multiplying directly on the x by 2, it's going to be a horizontal shrink. Because now we're going to take all our x values and divide them by 2. So 0, 0, x is 0, x divided by 2 is 0. Here we're at 1, 1. So x is 1, so it's going to shrink by a half. Here x is at -1, so it's going to shrink by a half. Here x was at 2, so it's going to shrink by a half. And here x is at -2, it's going to shrink by a half. So all my x values have shrunk by a half. Then we do the multiplication. So we have multiplied, so this is a vertical. And this is going to be a shrink as well. Oops, shrink. Because what we're going to see here is that all my y components are going to be multiplied by 1/2. So we're getting half of my y components. So here, this point was at 4, but now it's going to shrink down here to 2, y was at negative, sorry, y is still at 4, but shrinks down to 2. Here, y is at 1, but it's going to shrink down to 1/2. Here, y is at 1, but it's going to shrink down to 1/2, and 1 stays the same. So let me get rid of that blue line because this is too much in this little area. We've got 2 little shrinks going on here. Then my last bit is that I'm subtracting by 1 on the outside, so we're going to shift down by 1. Let's come down here. This is at 1/2, so it shifts to negative 1/2. 1/2 shifts to negative 1/2. This is at 2, so it's going to shift down to 1. This is at 2, I'm going to shift down to 1. So let me get rid of the pink part. Okay, let's see if I can get rid of that pink without getting rid of the green. Okay, it's probably best I'm going to do. So a very compressed graph that is shifted down 1 unit.